and delta V note corresponding small changes in P and V. Express delta P over P in terms of delta V over V2. So how here P is equal to Vk is equal to K over V. So which is equal to K V power negative 1. So the P, the V is equal to negative V power negative 2. This is equal to negative K over V squared. Which implies that therefore, so our delta P from small changes is approximately equal to V, so therefore delta P equal to V times delta. So this is approximately equal to negative K over V squared, and the delta V remains there as delta V. Our K is equal to P, so delta P is equal to negative PV and the K over V squared delta V. So we have one P going, then we shall have now delta P over P is equal to our negative dV over V2. Yes. Negative comes up. Negative, please notice. Negative is not a power. Let's start figure. This negative here is not a power, so there's no way. I think when you will say cross it this side, you will say the class this is equal to this. Instead of this in terms of that. So I've got our P and delta V over V. This one in terms of this. So what is this in terms of that?
Excuse me, teacher.
Yes. I think that you can't go because it came with different things. Yes.
Excuse me, teacher. Teacher, that step
Yes.
where you're obstructing.
I want to explain that. Which step
This step where changing P is equal to negative PV out of V. Here.
This one
the
here.
V. No, this side on the right. No, on the right.
This one.
Down.
This one.
Down, not this side on the right. This side on the right.
This one.
Yes.
This one.
Yes.
Uh-huh.
I don't understand how we got to.
Our value K. K was given us as P what?
PV. Are we together now?
Are we together now? Yes. K was given as P what? K was given us as P what? PV. PV. PV is not it. Negative K over V. This one here. This one. 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 This
Yes.
So where there's a K, I'm V. And one V is cancelled with the one V down. Eh?
Okay.
Are you now following?
Yes.
And then V squared down. So remaining with P over V.
Yes.
Okay? Now I'm putting the P inside.
Yes, teacher.
So that is what they wanted to show. That's number 5. Any query?
No?
Okay, we go to number 9. We want to go to second. We must finish this thing of further different to this today. We have never stayed on it. Eh? We want to go and look at something else. Eh? You have run it off? How I wait? Should I wrap up?
Wait.
Teacher,
No,
obstruct.
wait.
Now I become opaque. Eh? I tell you I want to hear what you are asking. Now, now ask. I think you can now see your BP. I've run away from it.
We say that change B out of percentage B, there is a question that BP out of B. Now,
To the university, so the negative.
okay. Now, when you're going down, do you put equal signs or like proportional in this case?
No, you should just to get the PDB in terms of, huh? You do that's right. So long as you have the P over P is equal. Something will be divided, that's enough. Huh?
What about normal? Do you change?
If you want, you have to put proportional. PDB is proportional to. Okay. So this now this one was quotient. Okay? So you put P as a constant and differentiate. In class, be a constant and differentiate one. You get it, eh? So that's how this thing will do. So this will give you one and this one. So we'll have now this one carries me, eh? So we also put this one here to be plus, eh? Isn't it? We're using smaller changes, we're not using product notes. I used to here, I want to go and look at it. I want to go to my
Yeah, that's.
Just a little bit.
Chelimo, Faith, Chemutai. Can you indicate your combinations? Rashida, we don't know where you're supposed to be. That's why you are left in the common room. You don't know how to take yourself to your particular class. Again, you don't know how to put your names, your combinations. Put combinations in that can help you take you to class. Chemutai and Chelimo, and now Rashida has taken her. Oh, Chelimo has taken her. So Chemutai goes Gadeo. Yo, Chemutai, take yourself to class. Because you either put combination, I take you there, or you take yourself. Rashida and Chemutai, take yourselves to class.
Nnyo ku mizikiti wadde ebirala bikyaganye gwe ku muzikiti tovaawo kubanga ku muzikiti yetusibuka era wali akayumba ketusembayo okwebakamu bakaita jeneza wali okalabyeko mu maka g'omuntu kabeera ka ebakatereka oba oyagala oba toyagala ojja matizo oyitidde ku muzikiti
abakuba kada yakayize kati bakamulagaawo n'akayigirawo first time.
Naasoma basajja batakuliika abaawano tuli Madiina bamashekhe baatugamba nti ffe tugenda kumunyega tugenda mukubanga doozi mpola doozi agenda okweza emyezi ena ng'akyalinako n'akamu tebamugamba nti salako enviri bamuteeka mu class batandika muwayirivu yalaba yekka nti bino si bituufu nalaba yekka ebikomo n'abijjamu piri yagenda kati omu ku bakozi baddaawo ab'amaanyi mu Durban sheekhe w'amaanyi nnyo babuza amasheekhe nti mwavudde ku kyokuleeta omusajja ono wano batendekerawo amasheekhe aga nti ayinza okubaamu omugaso eri ensi ye ekyo kimu ekyokubiri obulungamu Allah yabugaba si ffe abatuufu Allah yekka yabamanyi Allah nti naawe Muhammad tubamanyi.
Yeah, we have 4 pi h squared.
Bino byonna masjidi ffenna tugenda era tokkizibwa kuba muntu ku muzikiti kubanga agenda okujjaawo amanyi amuleesewo.
Can you mute, please? Can you mute the one that put the class again?
Ensonga y'okugamba nti tulabika nnyo ku mizikiti
Teacher, it's not a student.
Double click on my computer. I can.
Lugasa, this one here. Lugasa, please don't disorganize our class. Lugasa. You are disorganizing our class by putting again the rasta. Okay. Well, you said Have you now recovered? I don't know how to go lost of how we are getting 4h pi h squared. Have you recovered?
Teacher, I can't hear you.
Yes, teacher.
Yes, now after, when you differentiate this with respect to h, you have the h is now 8 pi h. Is that okay?
Yes, teacher.
From smaller changes, delta A over delta H is approximately equal to the A, the H. So delta A is approximately equal to the A, the H times delta H. So we are having here our H pi H times so the H is 1. Our delta H is equal to what? To 1. I say to a unit percentage. Height not 50%. That is 1%.
Teacher, how is DH1?
Yes.
How is DH equal to 1?
Look what your question. They are saying that find the percentage increase in the total surface area corresponding to a unit percentage increase in height.
Okay, teacher. Thank you, teacher.
That okay? Unit percentage increase in height. So now we shall have.
Excuse me, teacher. Teacher, on the third step, when you're finding after the surface area, then that third part, you say that surface area is equal to 2 pi r squared plus 2 pi r h. Then the next step is saying 2 pi h squared plus 2 pi h squared. Now where's the r squared going?
R is equal to what? Look at your question at the beginning.
Okay.
Have you recovered?
Yes, teacher.
So now we are looking at so now our delta A over A. We shall have now 8 pi h divided by 4 pi h squared. Then area was what? So we shall have this one 1% of h, 1% of what? H is 1 over 100 times 1 over 100 of h. So h over 100, h over 100, sorry. I forgot. Our delta h is 1 over h over 100. So we shall have now this one giving us 8 pi h squared over 400 pi h squared. So this one will go 8 over 100 gives us what? 59. Yes?
So how do you know delta H?
2%. Yes?
How do you know delta H?
Delta what?
Delta H, how do you know?
They told us, look what you asked statement. You know, maybe I'm not read the question you're answering. Can you read the question first? Those who have not yet read it. Because you don't know what we are answering. They have told us to find the percentage increase in the total surface area, but corresponding to a unit percentage increase in height. A unit percentage what? Increase in what? In height, 21% of height. Hello?
Teacher, we can't see the lower part of the board where you've written the answer.
Okay, then I will talk. We are having our delta H as H over 100. So this would be 1% of that. So now our delta A over A will be delta A will be now 8 pi H times H over 100 over area, which is 4 pi H squared. So then you have here 8 pi H squared over 400 pi H squared. So this one will go with that, and this will give us 2%, 2 over 100, which is 2%. Is it okay? It's given here.
Yes, 1% is H. Don't you multiply it?
Until 1 times H over 100, you get H over 100. You get 1%.
Yes, teacher, that's it. But don't you multiply it there?
And it's a multiplying here.
There.
Where?
Here.
It is the DH here. It's the DH here. I'm not just substituting. So I'm substituting here.
Already given us the value of the H.
They are not yet substituted. I substituted here. They were the data H I put this. Girls, are we together now? Hello? Is it okay now?
Yes, teacher.
So we are moving to our new topic right now. This is enough. You can do the rest.
Great powers were being. We saw the interest of each country. What did it want to achieve? What did it want to achieve? So at the end of it all, each country had hidden intentions. For example, Russia's aim was to support the Greeks, was to disintegrate the Ottoman Empire. While Britain and France never wanted Russia to disintegrate the Ottoman Empire alone. That's why Britain and France supported the Greeks again. That's why we're saying it exposed the hidden interests of the great powers with when the Greek War of Independence succeeded. So this one again is negative. It can't be positive. It is negative. This we add another point. The Greek War of Independence led to outbreak of other liberal and nationalistic movements, other liberal and nationalistic movements. The Greek War of Independence inspired the outbreak of other liberal and nationalistic uprisings or movements. The case in point is the outbreak of 1830.
The square, the x square is equal to d, dx times dy dx. That's how we define second derivative. That if you have the square y dx with the same as differentiate what you have already differentiated with respect to that second derivative, right? So if I have y is equal to 3x cubed plus 2x, and then I say dy dx is 9x squared plus 2. So my d squared dy dx squared will be the dx of 9x squared plus 2, which will now give me 18x. You are differentiating what you have already differentiated with respect to the same value. Is this okay?
Yes, teacher.
That's what we
I
mean by
beg your
sec.
pardon.
They're saying they will give you a function and then they say find the square, the y, the x squared. They mean differentiate that thing twice. So if we are doing the first time, I'll get the y, the x. Now the square, the y, then it will be again.
It brings back echoes.
It brings back echoes.
Yeah. Now, what you can do, you unmute your phone. There is someone recording. I don't know if someone is interested in doing that. Just mute your phones. You'll get my voice clearly. Okay, can we continue? Can we continue?
Yes, teacher.
Yes, teacher.
The Greek of independence.
However, if my y is in terms of t, for example, x cubed, okay, t power 3 plus 1, and my x is 2 squared plus 4, and I want to find the square, the y, the x squared. This one now will be d dt times the dy, the x, but I have to multiply my answer with dt, the x. Why? Because from chain rule, if I cancel this one with that, then I'll get my formula here. If I cancel this with this, then I will come up with this, which is the real definition of our second derivative. So when you use the defined parameter, after getting the y, the x, of course, in terms of t, get again the dt of that, then multiply it with your reciprocal.
Haji Cow has disappeared.
Where has he gone? I think he has muted his video. Let us ask him to unmute. He's going to unmute. He's coming back. Technology.
Teacher, he has also disappeared.
If I have a question, yeah? They said d the y gives d squared y, not so? Then the x times the x, I thought it gives d squared x squared. Why is it giving d x squared?
I think x squared remains constant because the y is maybe it varies. You might be given another thing.
People, what was your question? Mr. Kauka's laptop had gone off. We are just trying to reconnect it. What was the question?
Let me ask again.
Okay, you ask.
In the first part, they said d out of the x into brackets, the y out of the x. Now when they multiplied d times the y, they got d squared y. And so then the denominators, the x times the x, I thought you get d squared x squared. Why are we getting d x squared?
Hey, okay. It is not, actually, we are not multiplying. We are not multiplying the letters themselves. We are just because they appear as if they are being multiplied, but they are not being multiplied actually. It's just a second derivative, like you differentiate twice. Even the lower part, for the upper part, it might appear to be a d times d, but it's not actually d times d. It's just like a function, second function of something. Like the dx and dx doesn't give d squared x squared because we are not multiplying. We are just getting a second derivative. This is just a version, a way of writing it. That part of ddx is just a way of writing that part. This thing. It's not very clear, but it's just a formula of writing it. It's not a multiplication in itself. You get what I'm saying? Did you get what I was saying?
Yes.
Yeah, it's just a function, but not a multiplication. Any other question?
Teacher?
Yes.
When we are writing like in the papers, is it like a must for us to put that to show that we are getting the second derivative? Is it a must for us to put that?
It's not a must write it. So long as you write, so long as you write d squared y over d squared x. You might not show how we come to that, because if the examiner asks for the second derivative, they just expect you to write this d2y. Actually, we call it d2y, d2x. Even if you don't break up in the other first part of d dx in two brackets, But that second example Haji Kauka gave, the one that had a t, you have to be careful with it, because the x is in terms of t and the y is also in terms of t. That is where I want you to concentrate most. Otherwise, it can end up giving you wrong answers. We are trying to reconnect back to Haji.
Okay.
Okay, so we are just a function. So it's not actually multiplication. We are not multiplying. It's just in the definition. Are we back?
Yes, we are back.
Okay,
yes,
so
teacher.
Haji is back. Your Haji is here. Me, Sendaula, I'm away.
Okay, bye, teacher Sendaula.
We are trying to make it clear for you. I want to connect the speakers. Can somebody speak that I can hear you?
Hello?
Yes, teacher.
Okay.
Okay.
Yes, teacher.
Okay, continue with your questions.
Okay, ready?
Thank you so much.
Ladies. You ladies over there, I know you're not responding.
Yes, teacher.
When you keep quiet, it's okay to start, right? Okay, now someone was asking why is that delta y, the square y means this, but here you don't have the square, the x squared. Then you have the x cubed. But what it means, this is a definition. It is not, we're not multiplying here, but it is a definition of second what? Derivative. But the square, the y, the x squared is given as dx. Then differentiating what you have already differentiated with respect to the same variable. So it is not mere multiplication like we did in your primary or what. So don't relate it with your multiplication that we to get this square we multiply there and didn't know. That is the definition which they gave for that. Yes.
Excuse me, teacher. And the second example, how do we get that thing that's in the
we are
bracket?
now going to work on it. We are going to work on it in PowerPoint. Now, we are going to, I was saying that in case y is defined in terms of parametrical in terms of t, and also x in terms of t, and I want to find the square, the y, the x squared. It means that first of all get the y, the x, because we get t and y in terms of then get the y, the x like we did earlier. Then we are going to do it second time, but because it is in terms of t, we shall say dt of what we have.
Don't go.
Multiply our answer with dt, dx, and the reason why, because our definition says ddx, but here we're having ddt. So there should be a dt dx here so that this dt can go with that and remain with ddx of this, which is the same as our definition. So we must always have the right definition of second derivative. So let us get dy dx first. By you getting dt. Now dy dt, like we did earlier, because this one already you know, this will be 3t, what? And here dx dt. Dx dt is equal to 2t. You should remember that? You remember that? Hello, ladies.
Yes, we remember.
Yes, teacher.
Yes, teacher.
So therefore, dy dx will be dy dt times dt dx, which will be now our 3t squared times 1 over 2t, which will be 3 over 2t. So that will be our dy dx, but it's in terms of t. So if they want us to find the second derivative, which is the square y dx squared, I now say d dt of our dy dx, which is 3 over 2t. But after doing this, I multiply my answer with the dt dx, which is now the reciprocal of dx dt, which is 1 over 2t. I first define this with respect to t, but multiply my answer with our dt what? Dx. And therefore this one becomes, I think 3 over 2 times 1 over 2t, which is 3 over 6. 3 over 4t. 3 over 4t. That would be our d squared y dx squared. Is that okay? Ladies?
Yes.
Okay.
So I beg your pardon.
I'm saying after getting our dy dx and 3 over 2t, then we come and differentiate it the second time. But because our dy dt is in terms of dt, our dy dx in terms of t, we shall say d dt of our dy dx, and we have to now multiply through by dt dx, which is good from here. The reciprocal of this is 1 over 2t. Then we multiply what we have got from what we have differentiated, and what we get is our answer. Is it okay? Are we together?
Yes, teacher.
So if we have x is equal to a, t squared minus 1, and y is equal to 2a, t plus 1, then we want to find dx dt and dy dt. So we shall have dx dt will give us a 2t. So this is 2at. And dy dt will give us 2a is 1. Therefore, this is 2a. So our dy dx. You have got another example. Yes? I've already finished. 3 over 40. That's the answer. Yes? You want to see? Yes? This one. I know it's true.
Right.
Okay.
Yes.
It's okay. Are we together? Hello, ladies. Hello.
Yes, teacher.
Are we moving together?
Hey.
Those who are through, this is the second example. Given x is equal to that and y is equal to this, find the square y, the x square. Yes? Given. Find the square y, the x square. Yes?
Excuse me, teacher. Excuse me, teacher.
Yes, please.
Excuse me, teacher.
I'm here.
The last step. The last step. What did you cancel out? So I saw you canceled some values, but I'm not sure what.
I was canceling the 2a.
Of the second,
the 2a
the second
here,
part.
t, and then there was the 2a here of y, the y, the what? So I was cancelling this and that. Eh? Is that okay now? Is it okay?
Yes.
I have an answer.
Yes?
I have an answer.
What are you getting your question?
I have my answer as 1 out of 284.
Well, we have got the y, the x. Now we are going to find our the square, the y, the x square. I think we are going to move it very fast. That's very good. And some people understand very fast. Others take some time. So the square, the y, the x square which they want now will be dt of our dy dx times dt dx. Now this will be dt of 1 over t. Then after that we multiply with our 1 over 280. So if this will be equal to now, this will be our dt of t power negative 1 times 1 over 280 So we shall have now, negative t power negative 2 times 1 over 280. And this will be now negative 1 over 280 power 3 as our answer. That's what you have got? That's what you have got?
Not.
Is it okay, ladies? Negative 1 over 280 cubed. Eh?
Teacher.
Yes.
Elaborate how you have got the final answer, like the multiplication part of negative 2 to the power negative 2 times 1 out of 2a.
We this thing here is same as negative 1 over t squared, isn't it? Negative 1 over t squared is this. Eh? You know how I got this? Then this one here times this. You should get this. Is there any problem? This one here is negative 1 over t squared. And we multiply with 1 over 280. What do you get this? Yes?
Excuse me, teacher.
Yes? This time, please, don't you get it?
Yeah, we get the point.
Negative t. How do we get negative t? Understand how we get negative?
You understand?
Excuse me, teacher.
You have understood?
Teacher, excuse me.
It's okay.
I understand.
Okay.
But I understand how we get.
Yes?
Teacher, excuse me, teacher. I understand how we get negative.
You are not very clear.
But how we get it to be negative?
Negative, we are differentiating T power negative 1. This is our n. It is n, T, n minus 1. So if my n is negative, we have negative T, then negative 1 minus 1, which will give us that. From our formula, you have forgotten. Hello? Hello?
Teacher, I have understood. Thank you.
You have understood, eh? Okay.
I have understood.
Yes,
Let's get
teacher.
another example. So, what another example? Interference here.
No, this laptop has low volume. The laptop is a problem. It has low volume. The laptop, let me increase here. Hey, it was lost here, huh? But you also know to increase, isn't it? You also know how to increase the volume. Hello? Hello?
Yes, teacher. Yes, teacher.
Okay, it's okay. There was a problem with the volume.
So, one look at one more thing and close and prepare for the
You have prepared to Mr. Lubega at 11.
So, one more example here and we close.
But make sure you join with the right names because you are doing roll call, and some of you are putting D, you are putting the beach bat. This girl, this how you know I put funny names. Beach.
It shall pay you for freaking names, eh? So this is x squared over x plus 1 power half. Huh? So if they want the square, the y, the x squared of this shall have to begin by getting dy dx, and then again define the second term. So dy dx, dy dx should give us our v is x plus 1 power half, and here dx is 2x minus our which is x squared, which is a half x plus 1 power negative a half. And of course, times 1. Huh? And then everything over x 1. We're using our quotient rule. This is our u.
Understood. Please slow down.
Hey, we did the quotient rule with you ladies. You've already forgotten. uv du dx minus u dv dx over v squared. I hope you're now experts there. Eh? So
Yes, teacher. Yes. No. No.
That's why I was feeling go. You need this for a long time ago. And I hope everybody is comfortable. So if you're not comfortable, tell us where is your shit. Eh? Yes. Yes. Hello? Tell me why you have not understood and I explain. Because I thought we are okay with wash and roll. Yes? Someone is saying something.
Teacher, you just begin again.
Yes? We are different. One find the square the y, the x squared over this. And I said this one is our u, and this one is our v. Square root means 4 half. Huh? And we did that with you. Hope you are not forgetting very fast. So now it is v du dx minus u dv dx over v squared. Where is the problem, ladies?
See, there's no problem.
So the dx will now equal to our x plus 1 power half. And this is 2x minus a half x squared, then x plus 1 power negative a half over x plus 1. Now I told you we have to multiply through by x plus 1 power half and also x plus 1 power half, like we did last time. We want to simplify our numerator. This one will give us x plus 1 and 2x minus, now this will be a half x squared. Everything over x plus 1 power 3 over 2. Open up the brackets. You have 2x squared plus 2x minus a half x squared over x plus 1 power 3 over 2. I think we can correct like it times.
It's what I've written in the corner. I can't see what that.
This one is 3 over 2.
No, like up.
Up. This one is x plus 1 power half.
Okay,
put it up and down, the same as this. You remember how we are simplifying quotient rule, remember?
Yes, teacher.
And then from there, we collect the like terms, and we shall have our divided, giving us, I think, 3 over 2. X squared, yes, plus 2x over x plus 1 power 3 over 2. Yes. Yeah, also. We are multiplying through. I want to say we're multiplying through by x plus 1 power half. Did you get power 1? And then you get power 0. So you can bring out down the half and say 3x squared plus 4x over 2x plus 1 over 3 over 2 as our dy dx. So we just need to again to divide that thing, we go to x. I think we shall stop there, we'll finish that. Because time is not there. So you guys run around. You need to rest a bit. So from here, get the differentiate again. Our 3x squared plus 4x over 2x plus 1 power 3 over 2 again. And this one is your u, and this one here is your v. So we finish it off. Now, please, ladies, you are going to try exercise. Exercise 1, 7F. 7F, you look for those numbers of second derivative. Exercise 7F, all the numbers with second derivative. Numbers with second derivative. Yes. I'm saying, look at exercise 7F.
The second,
on page, yes?
the second
what?
teacher.
Yes.
The part of half x squared, where we started dy dx. When you put 1,
and when you multiply this one with
and x plus,
did you get x power?
I thought you get 0, so the whole thing is 0.
It becomes 4. Oh, x times the power 0 is what? Something to power 0 is
1. Okay.
You are putting 0. Okay, try this exercise 7F. Look for numbers with second derivative and do them. Now we are through with this further differentiation. You will do all that miscellaneous exercise for other parts, which we covered earlier. Next time we meet on Wednesday, we are going to have something different. Please finish off this question. This is now your U. This is now your V. Again, go with the quotient what? Rule until you get the final answer. That's how long the quick question can be. It covers a lot of marks.
Excuse me, teacher.
So wait for Mr. Yes?
Is that 3/2 or 1/2?
Which one?
The last parts of 2 into brackets x plus 1.
Oh, 3/2.
That.
Oh, 3/2. Which will go there when you add 1 plus half. You get 3/what? There's a 1 here and there's a half. So 1 plus a half is 3/2. Have you seen it? Yes?
So where did you get for x?
Get what?
Where did you get 3x squared plus 4x?
This is the over 1. Master primary is this time. This is the over 1. If you put on the same LCM, it will be 2 times this, which is 4. But the whole thing now is over 2. If I have got 3/2x plus 2x, this is the whole number. So we put under LCM, this will be 2. 2 goes here once, this is 3x squared. Plus 2 goes here 2 times 2, 4x. Do you know that math of primary?
Yes.
Have we now seen how it becomes 4 and how the 2 goes down?
Yes.
Okay, thank you for attending. Some people have already left, I can see.
Yeah, what?
Before the other lesson ends. So please wait for Mr. Lubega is coming.
Part 2 mechanics.
Part 2 mechanics. You need to rest a bit.
What exercise is
I'm giving it to 7F. Look for the numbers with second derivative. You know, some of you go away and then you come back when I'm giving the work. Ask your colleagues. So bye-bye.
Somebody say bye to Haji Kauka.
Takia, hi.
Bye,
Bye, teacher.
Bye, teacher.
Bye, Haji. Bye, Haji.
Yeah, good. You said bye, Haji. Yeah,
Bye, Haji.
You say bye, Haji. Our dear Haji.
Bye, dear Haji.
Hello.
I know.
Bye.
Hey, you also say bye to our dear Sekulima.
We don't want.
Bye, let me hope he has not heard.
Sekulima. Bye, Haj. Bye. Sekulima. Bye, Mr. Bye. Bye, Haj.
Thank you.
Nah, you go bye.
At least you do this coming in Lubega. I know guys are waiting.
Nothing. We shall miss the lesson.
People are waiting for dear Lubega, the dude.
Dear Sendola, if you buy each one, no?
How people can be happy with
Mr. Sendola, bye.
Bye.
Bye, you go. Bye,
Let me close. Mugende munywa chai Mr. Lubega agenda kutandika.
Bye, Mr. Klima.
I'm still here.
Bye, Sendola.
Moving away.
Bye, Mr. Klima.
We're fasting. It's not going away.
I'm here, I'm not leaving. I'm not going away. I'll say bye bye in the evening. Extra. Money, I can't come and get it.
I'm going to. No, because from I don't text it. What?
Hi, Adoyo.
Hi guys, how are you?
Fine, how are you?
I'm fine. Who is that?
Karen.
Karen.
Adoyo.
Yes.
Karen. Yeah, this is Lucy. Inbox we talk. I need some help somewhere.
Tell me, who is talking to you by now?
Karen.
Lucy. Oh, Lucy, you got an inbox Karen yesterday. I have only one number.
This is Aliero Lucy.
Oh,
Lucy. Can you save your data and go away? You're not talking about the data.
Teacher, we have enough.
You're not applying data. We have no data. What? Oh.
Not that.
Aliero. Aliero, I'm online now.
Mr. Sendaula.
Angie.
Mr. Sendaula.
Yes, dear.
Would you please buy for us?
I buy for you what?
Never mind. How is Ramadan?
Ramadan is very sweet.
Hey, that's good to know.
I'm going to bring for you ED packages. By Sunday, Monday next week should come and pick.
Oh, teacher, we are waiting. Hey, teacher, we come. Listen through Jumia.
Jumia guys are faulty these days. I no longer use them.
Okay, teacher, I'll send my personal number that is true.
Yes, that's better.
Is it okay for me?
Okay, teacher, this is Angola. It's Karen. I will send by Wednesday.
We are saying packages are next week on Monday.
Which packages?
Oh, okay.
Package. What they call a package? You unpackage from home to see what is there.
Yes, teacher. Aunt my brother is unpicking.
Aunt, you send on Monday at 9.
On Monday?
Yes.
Hey, yo, how are you? Who is Amra?
Hi.
Hi.
No,
where you guys going to take it?
Wanji?
What?
Teacher, don't forget. This is
your eyes. Even the mouth I can't see.
I cannot forget.
Hey, teacher, we have agreed.
I'm the one who has said, I'm not forget. Then you're saying, you teacher. Maybe it's okay. It's you to forget sending the border. Don't forget. Maybe you forget sending the border.
I won't. I won't forget. Okay, it's a quick question. The way I had left the number, I've tried to apply question 2. Now I'm stuck. Where to multiply assignment 1? Should I multiply 2x plus 1 to the power 1 or 2x plus 1 to the power a half?
Can you show me what you're writing? Just put your video on and show me.
Okay, teacher.
Hey, Lynette, what's your problem, Lynette?
Yes, teacher.
Okay. Teacher.
Level no wachi. So you're saying the problem is where? Where is the problem?
Whose problem?
Okay, I'll check it later. Let me first create rooms for the next class. I'll check it later. Eh? Can you please join your classes? We have recreated other rooms to cater for History 6 and History 1 plus Math. Can you please join again your classes? People of History 6, History 1, select your subject and join. Because you are Lynette. Lynn.
Where is the lesson here? Okay. Now, this is common room. Come and enter. The main Haji has been teaching here.
I hear you.
Yes. Teacher,
Sorry, Mr.
is here.
How are you?
Who is?
I dare tell Mr. I would like to come and join us in math.
I'm coming.
Which teacher? That teacher is ready.
The breakout room.
Oh, they are putting him there. Don't worry.
No, it's not. But automatically, maybe because you are also.
They have. Oh, there's a way teacher does it. What teacher does it?
Just forgot. Mr. Twan. He has been around.
What is that?
What's wrong?
Teacher, the girls you were talking about, they went for.
Join. Yes. Join, man. It was just a matter of that way with my God. That's when I started at 48. Good morning. Morning, class.
Good morning. Good morning, teacher.
Get ready.
How are you, teacher Lubega?
I'm fine. How are you?
We are all right.
Yes. I don't know if you can remind me about the last question where we stopped. We are going to get the question of line of action. Equation of line of action. The resultant actually it was a square. The resultant and direction. Then the equation of line of action and where it cuts the side AB. So basically, when you come across such numbers, you have to read the whole question before you sketch the first diagram, and make sure you put the line that the resultant is supposed to cut along the horizontal or vertical, because we use the concept of coordinate geometry, coordinates. A straight line cuts the horizontal axis when y is 0, the i.e. the x-intercept, and the y-intercept when x is 0. So you have to read the question. So it was a square. Acted upon by forces. It was square ABCD. Acted upon by forces. They gave us, can you remind me?
Teacher, we are not seeing that side.
Okay.
Yes, we are not seeing that side. Teacher, we can't see the other side.
Okay. Can you see that the square?
Yes, teacher.
Yes, teacher.
So now it was square ABCD, and they gave us forces. They said forces of 8 newtons
10 newtons.
10 newtons.
8 newtons.
8 newtons.
6
4 newtons.
4 newtons.
and 4
and 1 newton.
2 and 1.
Sorry, 2
And then 1.
and then 1. We cancelled out 1 newton because the number of forces were exceeding number of sides. This was acting along which side?
Sides. AB.
It was acting along AB and then CB,
BC.
BC,
AB.
AB,
AB.
AB,
PA.
and CA. Yeah, so those are the forces acting along the sides. The forces acting along the sides. So we make sure the direction of those forces along the order of letters. The order of letters will give us the direction of forces. So now side AB, along AB, A to B, we have 10 newtons. Then C to B, 8 newtons. And D to C, 6 newtons. A to D was 4 newtons. And then we have the last one is a diagonal force, which is acting along AC. Sorry, they say CN. And that was 2 newtons. And don't use freehand to draw the force diagram. Now, because this is a square, last time we saw that the diagonal should make 45 degrees. But if it's a rectangle, then the diagonal angle should be calculated first. For a rectangle, you have to calculate the diagonal force. For a square, sorry, the diagonal angle. For the square, the diagonal angle will be 45 degrees. Because we need the 45 to resolve the 2 Newton's force. Sheena, please, you need to mute from that side, Sheena. Now the resultant here would be, so we resolve, you see that 10 Newton's force is acting along the positive x-axis. So this will be x is positive 10 and y is 0. And then plus the components of 8 newtons. 8 newtons is acting fully downwards, so the negative y. So there is no x, but y is negative 8. And then we move to the 6 Newton's force. X is positive 6 and y is 0, because the force is fully acting horizontally. And then plus we move to the 4 Newton's force. X is 0 and y is to the positive, so it will be positive 4. So we have resolved all the forces acting along the sides and then left out with the diagonal force only. We are going to resolve. Okay. So the diagonal force, who is Jackie? Jackie, please.
Jacqueline.
So we are going to resolve SC, but using the 45 degrees. Now, when you look at the 2 Newton's force, it's acting towards the A. It is acting towards this point. So we have the four. Please, Jacqueline, mute that side. Now the 2 Newton's force is moving towards the point A, meaning that its components should also move towards that same point. Now towards the A, the horizontal component will do this, and the vertical component will do that. So that means the X is negative and Y is negative. The force is moving towards the point A, and so should the components. So the horizontal component towards the A is negative, and the vertical component towards the A is also negative. So that will give us -2. Now this horizontal component is adjacent to the angle 45 and therefore goes with cos 45 degrees. The vertical component is negative and opposite to the angle. So it is -2 sine 45 degrees. So you have to be
Could you please repeat?
And you should be careful with that resolution, because once you mess up with the signs, then you lose the whole thing. Plus this, I'm saying that the 2 Newton's force, there is a difference between these two diagrams. The 2 Newton's force moving towards a point such as A, and the 2 Newton's force moving away from the point A. These two things are different. Here, in this case, the components will move away from point A like the force does. So horizontally away from A and vertically away from A. So in this case, the horizontal component is positive and the vertical component is also positive. This will be, and this component here is adjacent to the angle, therefore goes with the cos. So it will be 2 cos 45 positive. Then this component will be positive 2 sine 45 degrees, because it is opposite to the angle of resolution, goes with a sine. Now, when you look at this case here, the force is moving towards the point A, and so should the components. The horizontal component towards the A, and the vertical component towards the A. So here, X is facing the origin, all negative direction. So the horizontal component is negative, and the vertical component is also negative. Horizontal component is adjacent to 45, and therefore goes with the cos. Vertical component is -2 sine 45 degrees, because it is opposite to 45 degrees. So please, people make mistakes, even those who know how to resolve forces, because they don't pay attention to details of the forces and direction. So you should be careful. So that will be plus, let me add it here. Horizontally, X is -2 and adjacent to 45, -2 cos 45 degrees. And then vertically towards the A is a negative, -2 sine of 45 degrees. So those are the components of the 5 forces we have resolved. So without wasting time and without any simplification, you get your calculators and you get the answers. You add the horizontal components, you add the vertical components. add the horizontal component, add the vertical component.
14.58.
John, 14.45858. Right? So you confirm the horizontal component.
Negative.
You confirm the horizontal component. We have 14.45, sorry, 5858 positive. The vertical component.
Negative 5.4.
Negative 5.4142.
42 newtons. Please, a minimum of 4 dPs. This is not physics, not econ, not geography, not what? Applied mathematics. We want a minimum of 4 decimal places and make sure they are rounded off correctly. Now, some people will even underline this. Even if you talk about it 100 times, people will underline this as the resultant. Means those are components of resultant. In fact, some people even give them in IJK form as 14.5858I minus 54142J newtons. Please, that is not the resultant because these forces here were not given to you in terms of IJ form notation. So we should also give our resultant in terms of magnitude and direction. Just like the question, if they say find the resultant force, it must be given in terms of magnitude and direction. Because resultant is because the force, resultant force is a vector, should be given in terms of magnitude and direction. Unless they mention find the magnitude of the resultant, that is where I only get magnitude and not direction. So we continue, we get the magnitude. This is part A of the question. Now the magnitude of the resultant denoted as R magnitude would be the square root of the components squared. But as I write this, I'm seeing a negative somewhere, meaning should be in brackets. So if you don't put this component in brackets, you're finished. So we get this till 4 dPs minimum. What do we get, John?
15.558.
15.582 newtons. So you confirm that answer, the resultant, that's magnitude. And then we look for direction. And remember what we said last time about direction. These are the components. The horizontal component is positive. The vertical component is negative. So you join the two components. But remember, once the first diagram for the components is wrong, then you're likely to lose the marks for what? For the direction. So the horizontal component, we draw the straight line representing horizontal component to the positive, and that would be 14.5858 newtons. That is the size of the line, and then we connect a vertical component which is to the negative. So y is negative. So you see my component is acting downwards. And then after making it downwards, you don't include the negative sign. That negative sign is then implied by what? By the direction of the arrows. So because this is horizontal and that's vertical, you indicate the right angle, and then you join the direction from the starting point to the end point. I gave all the options last time in our introduction. If the line is dotted, then put one arrow. If it is solid, then you put 2 arrows to distinguish it from its components. So this is the resultant. Some people will just draw the dotted line and will not indicate the resultant force R. Or others will draw it and put R without direction. All those are wrong cases. So R is acting at theta to the horizontal. So we want to get theta, and you see we have adjacent to theta and opposite. So you use tan, or you can even use cos or sine since you have R. So tan theta, and when you shift tan, theta will be the tan inverse opposite to adjacent, 14,5858 newtons. What do we get? 20.3648 degrees. So you conclude, therefore, the resultant acts at 20.36 degrees to the horizontal. So the resultant is acting at 20.3 degrees to the horizontal. And that's enough. You don't even need to mention below the horizontal or what, because we can see that from the diagram, that it is acting at theta below the horizontal. And if you don't give such a conclusion, you can use the bearing for direction, it's okay. You see where the resultant is projecting from this point here. So if you want to use direction, you can put an imaginary north line, but not using freehand. Don't use freehand to put that imaginary north line, because it will make the diagram wrong. So you can see it is running from east, that angle theta towards the south. So you can say east 20.36 degrees south. Can give that, but there is no need for you to give both. You know, some for can give the direction in two using two alternatives. Can Gisha please?
So we can't down that side.
Okay. Okay, so down there is the conclusion for our resultant. It says the resultant is acting at that angle to the horizontal. The resultant acts at 20.36 degrees to the horizontal. Or you can even use the direction, the bearing form. So that is part A. So for all other examples, I'll even skip that part unless you have questions. You can try part B. I left this question last time. What was part B saying?
Find the equation of the line of action of the resultant force and height, or otherwise determine the point where the line of action touches the area.
Okay, so they wanted us to find part B, the equation of line of action of the resultant force. They wanted us to find the equation of line of action of the resultant. So, equation of line of action. Now, the equation of line of action will depend on the point where the moments are taken. And the point where moments are taken acts as the origin, The point where you take moments will act as the origin. The equation of line of action. So equation of line of action is given by, now since they want they finally want us to find a point where it cuts side AB, that means we take moments along the line AB. So taking moments about point A, the equation of line of action will be given by the determinant of the x, y, and then the sum of forces, summation x and the sum of forces along the y-axis. So it can be given by this, you know, any straight line should have x and y variables. So you can see we have x and y, and then so the equation of line of action is given by this formula. Is it John? I was talking about the straight line. The straight line y is equal to mx plus c. You see this resultant, the dotted line here, is a straight line. That's why we are talking about its equation. Equation of a straight line. This equation should be in the form y is equal to mx plus c. So we need the variables x and y. They are given by the first column, and then the last column is given by the components of the resultant, which are 14.5858 for sum x, and the sum y is negative 5.4142. And if you're using the concept, clockwise moments are negative and anti-clockwise are positive, then strictly this equation should start with x, y, the variables, and end with the forces, either vertically or horizontally. The equation of line of action strictly should be this, or given as the determinant x, y, sum x, sum y, any of those two. But strictly should start with x, y, and then finally the forces. That is, if you're using the condition that clockwise movements or clockwise moments are negative and anti-clockwise moments positive, then the equation should be in this form. And I advise you use that. Don't change, the other one will confuse you. So that means before I continue, there are some people who write the equation of line of action in matrix form. Someone writes such a thing, or someone writes the equation of line of action in this form: x, y, sum x, sum y. So when you state your equation of line of action using any of those two, that makes it wrong. It makes it wrong because now this symbol does not describe determinant. These are matrices. This is a matrix symbol. This is also a matrix symbol. So strictly, the determinant symbol are the vertical bars, two of them. Now to get this equation, we need to get G, whereby G is the sum of moments. G is the sum of moments. So, so that G we take moments. We are going to take moments about point A. But the first rule is, if the line of action of a force is passing through point A, then that force has no moment, i.e. the 10 Newton's force is passing through point A and therefore has no moment. The 4 Newton's force and the 2 Newton's force. Those three forces are passing, their lines of action pass through point A and therefore have no moment. So we have the 6 Newton's force and the 8 Newton's force only. Now, the 8 Newton's force is a clockwise turn about point A, and therefore its moment would be negative. The 6 Newton's force is also clockwise about point A, and therefore negative. Now, the perpendicular distance of the 8 Newton's force from point A is the length AB. And the perpendicular distance to the 6 Newton's force from A is length AD. But since this is a square of side 2 units, that means we have the same perpendicular distance drawn. So the moment of 8 being clockwise, negative, force times perpendicular distance, which is 2, plus the moment of 6 Newton's force is negative because clockwise, then times the perpendicular distance, which is again 2 units. So this will give us negative 16, negative 12, negative 20, negative 28. Now, we don't even need to give the units there because they did not request for
Excuse me, teacher.
yes.
Teacher, why is our 6 a negative?
No, because it is a negative moment, because it is a clockwise moment. Clockwise moments are negative and anti-clockwise positive. Do you see how the 6 Newton's force is clockwise about point A? It provides a clockwise turn. That's why it's a negative.
Yes, teacher, I've seen. Thank you.
You're welcome.
Teacher, why?
I beg your pardon?
Why are you multiplying by 2?
Oh, we are taking moments. A moment is the product of force and its perpendicular distance from the turning point. The product of force and the perpendicular distance of the line of action of force from a turning point. Now the turning point is where you take moments. We are taking moments about A. So the perpendicular distance should be measured from point A. Now, this is the 8 Newton's force, and its perpendicular distance from A is the length AB. Length AB is going to be the perpendicular distance. Length AB. And remember, in the question they said the square ABCD is of length, is of side 2 units. So AB is 2 units. That's why it is 8 times 2, but negative being clockwise. Now the perpendicular distance of this 6 Newton's force from point A is AD, which is also 2 units. Yes, and.
Why do we ignore that? Why do we ignore that?
Why do we? Jaya, why do we? I beg your pardon, Jaya. I don't know, and Jaya. Maybe Jay.
It's J-I-L-A.
Yeah.
Why did you 8 or 6?
I can't hear. I can't hear. I can't hear. Okay, let me repeat this. Now,
8 and 6.
8 and 6. Okay, now attention. When you're taking moments about a point such as A, now all the forces which are projecting, all the forces whose lines of action are passing through point A have no moments, such as the 10 newtons, the 2 newtons, and the 4 newtons. Those forces have no moments because they have zero distance from A. Their lines of action are passing through point A and therefore have no what? Have no moments. So in this diagram, the only two forces that have moments include this force here, the 6 Newton's force, and the 8 Newton's force, which is acting downwards. Only two forces. 4 Newton's force, 2 and 10 have no moments. Now, this force here, the 8 Newton's force, has a clockwise moment. When you bring it closer to the point, it is acting downwards, but you want to rotate it about this point A. So when you continue with the rotation, it gives a clockwise turn. That's why it is considered negative. And then the perpendicular distance of the line of action of this force, the 8 Newton's force, is the distance from A up to point B, which is 2 units. It was given in the question, 2 units. So that moment about point A is going to be negative because it is clockwise. The force is 8 and then multiplied by the perpendicular distance. The perpendicular distance from point A to the force along this, its line of action is 2 units. So times 2 and then plus, we move to the 6 Newton's force. First identify the type of rotation. So the 6 Newton's force is above point A and doing this turn. I'm not saying you start putting those arrows in that first diagram because it makes it wrong. It is above point A and the rotation is again clockwise. So it will be a negative moment. Negative. A moment is product of force, which is 6 times perpendicular distance. The perpendicular distance to 6 Newton's force above point A is the distance AD, which is also 2 units. So that's why it is times 2. So this will give negative 16, negative 12, which will give negative 28. The units will be Newton units, but they did not request for them. Should you state them and they are wrong, no one requested for units, you better leave them. Now we have got G and we have already the component. So we substitute and get the determinant and the equation of line of action. So when you substitute, we shall get G, which is negative 28, is equal to the determinant xy, determinant xy, the sum of forces, the x component, what was it? 14.5858, and the horizontal vertical component was negative
5.4142. 4142.
So we get the determinant and hence the equation. So this is negative 28 is equal to, you know how we get the determinant from O level? We get the cross product, the product of elements in the leading diagonal, x times this 4142x minus the product of the entries in the secondary diagonal. Minus 14.58 58y. And that is the equation of line of action. If you want, you can divide all through by a negative, but it is not necessary. It is not necessary. That's the equation of line of action they wanted. And the question was saying, determine the equation of line of action of the resultant, hence or otherwise, the point where it cuts the side AB. Now, this is a straight line. And you see that side AB, since we have taken moments about point A, the line AB will act as the x-axis, and the line AB will act as the y-axis. So to find where the line cuts the side AB, we use the concept. Any straight line cuts the x-axis when y is 0. So let me use hence. We say the line cuts AB, and AB is the x-axis when y equals 0. So we substitute 0 here. That will leave us with negative 28, negative 54142x. When you put here 0, disappears. So you divide, and what do we get as x?
5.1716.
5.1715.
16. Yeah, but then that is not the answer. You're supposed to we're supposed to conclude, yes?
Do we always have to equate the y to 0?
Yeah, because now, because the line is cutting AB and AB is horizontal. Because the line is cutting AB and AB is horizontal. Any straight line cuts the x-axis or the horizontal axis when y is 0. But if they ask you to find the point where the line cuts side AD, then any straight line cuts, AD is vertical. Any straight line cuts the y-axis when x is 0. It depends. But you better make the side the line cuts to be your horizontal, so that you can easily apply the concept. Now this is what we have got, but it's not the final answer. You're supposed to conclude. Now we have two cases. Now because A is the origin, that means measure this distance from point A. This is the origin. Now we have three cases. The first case is when the output here is positive. If the output is positive, that means you move to the positive x-axis. If it is negative, you move to the negative direction, this side. Now, we know that the distance from A to B is 2 units, but we have got a distance which is beyond 2 units, meaning you're supposed to produce line AB. The point will be after line AB. So in your conclusion, you have to mention AB produced. If you get a distance such as maybe 1.872, this distance is less than the 2 units here, meaning the point is within. So in your conclusion, you're not supposed to mention any line produced anywhere. And then if you get a negative answer, such as negative maybe 1.5, That means from A, you move to the negative side, meaning the line of action will cut line AB from this side, the negative side, and we have to conclude. This is B, A produced. This is A, B produced. AB produced, and this is BA produced. So you have to give a correct conclusion. So the point is here, we said therefore, the line of action cuts AB at 5.176 units from A along AB produced. So we say it cuts AB at 5.1716 units, because they do not give us the units. Units along units from A along AB produced. Along AB produced. It cuts AB at these units from A along AB produced. That's it. That's what.
Teacher,
Yes?
excuse me, teacher. For the third case, whereby we have 1.72, how do we conclude? Do we say 1.72 units from A?
Yeah. When positive, 1.7, you say it cuts AB at 1.17 whatever units from A. Only that, because you don't need to produce the line from A. That's it.
When it's a negative, when it's a negative, you're concluding, you say, do you put the negative in the answer, or you say you put the positive thing? Then how do you conclude it when it's a negative?
It's a negative. Now, if it's a negative, then it's a negative. Now, if it's a negative answer, that means from the origin, you move this side, so it will be here. Definitely, it is outside line AB, so you have to produce the line. So you say the line, you say it cuts, even if you don't repeat that, it cuts, and say at, or it cuts AB at, you don't put the negative, you say it cuts AB at that distance units from A along BA produced. From A along BA produced. What is very important there is BA produced. BA produced from A. If it is positive but less than 2 units, you say it cuts AB at those units from A. If you want, you can even mention along AB, it's okay. From A along AB, it's okay. If it is beyond, you say what you have given there. I've seen someone saying that where has the Y disappeared? When we substitute Y0 here, it will be minus 14.5858 into 0. So that's why the Y has disappeared. Yeah, that's why the Y has disappeared. Maybe let us try the next example, give us a negative and we see what happens.
So why did we conclude twice?
No, we did not conclude twice. We got the answer and this is the only conclusion we have. This is the only conclusion you have. Yes?
Am I saying is
But why did we get the points about A instead of the points about B or C or D? Because the question doesn't actually specify about which we are making the keyboard.
Okay, now the question says find the point where the line of action cuts side AB. Cuts side AB. So that means we are supposed to get where the line of action cuts AB. So if this is AB, the line of action is cutting AB, the line of action R. So which means you're supposed to choose any point along that line and use it as your reference. Reference, I mean, you use it as a point where you measure the distance from. But the point you have chosen is supposed to act as the origin. If you choose point A, then it is acting as the origin, according to the formula, the other determinant formula. If you choose point B, then the B will act as the origin. So that's why we chose point A, so that we can measure the distance from that. If you want, you can choose point B. Yeah, so you can't choose any other point from A and B, like point C and D, because it does not connect to the required what? Line. Yeah, that's why, John.
Okay, you get 1.17 and the unit, and you conclude it cuts the AB axis at 1.7. Yeah.
From A. From A.
The A is necessary.
Yeah, because you have to tell us where you measure the distance. Yeah, along that line, where is the distance measured? So I've seen so many questions. Maybe the next example will try to answer some of them. But a question was saying yes or otherwise. We have alternative that question. You may not use the determinant method. You can draw equivalent force diagrams. Did teacher give only one? The teacher gave only one.
Yes.
Yes.
He gave only that.
Yes.
Okay. Huh. And did you look at examples which specify, for example, they can specify a point for you. They can specify a point for you. The line cuts.
Which point?
They can, for example, the question they can even mention the line cuts given the resultant cuts side AB at point E, maybe along this produced T or whatever, but it's fine.
Not teacher.
The alternative can be this. If you don't use the determinant, then you draw an equivalent force diagram. But it is almost the same thing. Is the same thing. Let me put back the diagram. This diagram was A, B, C, D, and we had 45 degrees here. We had 10, 8, 6, 4. Can you give me the directions? And 2 newtons. This was, what are the directions? Then this was FD, yeah, that is the diagram. Now, alternatively, we can draw the equivalent force diagram. You see this symbol, equivalent diagram. the equivalent diagram and we put the resultant. So the equivalent diagram, you use the definition of a resultant. You pre-empty all the forces in the diagram. You empty them and represent them with their symbol force. You know the resultant is creating the same effect on this body as the so many other forces, as the 5 forces there. Now, since they want you to find the point where the resultant cuts the line AB, then, and we don't know where the point is, you know the point can be here or there or there. Those are the 3 points. Can be in between or AB produced or BA what? Produced. Now, because we don't know, we simply let the point be in between A and B. If I'm not seeing the point. But John, you have a question. You answered. Okay. You let that to be a point. Now, this is important because there are questions where they specify the resultant cut C line AB at point E along AB produced. And that will affect, that may not even affect you, but when they say along BA produced, then the other method can cause issues. So if this is the point where the resultant is acting, you put the components. We had the horizontal component as positive 14. So I put my component there to the positive, as you see, and my vertical component was negative, downwards. The horizontal component is 14.5858 newtons. The vertical component is 5.4142 newtons. Now the 2 components are both projecting from this point, and so should their resultant. Don't put the resultant diagonal. Don't put the resultant diagonal. So the resultant is projecting. You see the 2 components are forming a 4th quadrant. So the resultant is in a 4th quadrant, and it is the resultant R. You see it cuts line AB at this point, and we just want a distance from point A. We can let that distance be X, and that's now done. That's done. Now, because this is a resultant force, it is exactly a full representation of the previous diagram. Meaning, when you take moments, the sum of moments in this diagram about a point should be equal to the sum of moments in this diagram about the same point, because this is ideally the same force diagram. Many forces, a single force with its components. So when you take moments here about point A, it will be the same sum of moments about point A in this diagram here. As simple as that. But it's not different, so different from the other method, because again, we are taking moments about point A. So taking moments about point A, in this diagram, I will then equate to this. In this diagram, no moment for 10, no moment for 2, no moment for 4. We have 8 and 6. That perpendicular distance to 8 here, 2 units, to 6 here, perpendicular distance 2 units. This is a square. So 8 is clockwise, that is negative 8 times the perpendicular distance plus the moment of 6 Newton is here, again clockwise, negative 6 times 2, the perpendicular distance. I have got the sum of moments in this diagram. I'm going to equate it to the sum of moments in this diagram about point A. Now, about point A, 14, this component here, the horizontal component, has its line of action passing through point A and therefore has no moment, then the only component that has moments or that has a moment is the vertical one. And when you rotate the vertical component about point A, it is clockwise. It is clockwise. So it will give a negative term. So this equals negative 5.4142 times the perpendicular distance, which is x. So this gives you the answer directly. It gives you the answer directly. So when you divide, this is negative 28, negative 5.4144x. And this will give x as
1716.
Newton. Sorry, units, because they did not specify. So this gives the answer to you directly. Gives the answer to you directly. And here they can even forgive you because the diagram shows the point where it cuts side AB. But then, okay, this one is the 5.176 is beyond the 2. The distance x cannot therefore be in between because it is bigger than length AB, meaning we have to shift it. And because it's positive, that means it shifts to the positive direction. If it is negative, you shift it towards negative. If positive, you shift towards a positive. So this will give us the point supposed to be there. You conclude, therefore it cuts AB at, you give the same conclusion, at 5.1716 units from A along AB produced. So in the questions where they tell you where the resultant is already acting, we better use this. They can tell you the resultant is acting at this point between AB or along AB produced or along BA produced. So, but it is almost the same thing. I think we can continue. We have made the discussion, no? But that's fine. Other examples would simply be shorter. Yeah. So that's fine. Write quickly, and then we continue. Write quickly, and we look at example. Actually, I want to give a question for you to try, and then one more example.
So we have finished. So we have finished.
Okay. Question, exercise, 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 exercise. Mr. Brown, do you have a question, Brown?
Yeah, question back. Yeah.
She has. Exercise. Exercise. Okay, so you write the exercise. I want you to try do UNEP 2000 UNEP 2000 UNEP 2000 UNEP 2009 UNEP 2009 number 12 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 UNEP 2009 number 12. Then example, you write forces of magnitude forces of magnitude forces of magnitude forces of magnitude 1 Newton, One Newton, 2 Newtons, 3 Newtons, 4 Newtons, and 5 forces of magnitude 1 Newton, 2 Newtons, 3 Newtons, 4 Newtons, and 5 Newtons. Act along side Z, act along side Z, AB, BC, DC, AD, and the SC of a rectangle ABCD, of a rectangle ABCD, of a rectangle ABCD. Full stop. Given that the direction of forces are indicated by the order of the letters, given that the direction of forces are indicated by the order of letters, given that the direction of forces are indicated by order of letters, are indicated by order of letters, and the are indicated by order of letters, and the FB and FB is equal to 2 meters, and the AD equals 3 meters, and the AD equals 3 meters, and the AD equals 3 meters, and AD equals 3 meters. Find the magnitude and direction of the resultant force. Find the magnitude and the direction of the resultant force. Find the magnitude and the direction of the resultant force. Find the magnitude and direction of the resultant force. We'll stop part B. Determine the point where the line of action of the resultant. Determine the point where the line of action of the resultant cuts side AB. Determine where the line of action of the resultant cuts side AB. Cuts side AB. Cuts side AB. Full stop. That is
Pardon.
From so
For
part
a second.
Okay, part
A
A.
second.
Part A says find the magnitude and the direction of the resultant force. And then part B, determine the point where the line of action of the resultant force cuts side AB. Determine where the line of action of the resultant force cuts side AB. Cuts side AB. Cuts side AB. Where it cuts side AB. So that is fine. You can try the 2 questions, but before we go, I want us to look at this simple example. We have not looked at hexagon and the other shapes like triangle. I wanted us to look at the triangle. I wanted us to look at the triangle. Example is a short one. Example, you write forces of magnitude 10 newtons, forces of magnitude 10 newtons, 8 newtons, and 3 newtons, and 3 newtons, and 3 newtons, and 3 newtons, act along sides AB.
Teacher, that's another question.
Yeah, this is an example. It says forces of magnitude 10 newtons, 8 newtons, and 3 newtons act along sides acts alongside the AB, comma, CB, and the CA, respectively, and CA respectively, and CA respectively of an equilateral triangle, ABC, of an equilateral triangle ABC, of an equilateral triangle ABC, of side and an equilateral forces of magnitude 10 newtons, 8 newtons, and 3 newtons act along sides AB, CB, and CA, respectively, of an equilateral triangle ABC, of an equilateral triangle ABC, of an equilateral triangle ABC, of side 2 centimeters, of side 2 centimeters, of side 2 centimeters, of side 2 centimeters. Full stop. Full stop. The direction of forces are indicated. The direction of forces are indicated by the order of letters. The direction of forces indicated by the order of letters. The direction of forces indicated by order of letters. The direction of forces indicated by order of letters. Indicated by order of letters, full stop. Part A, determine the resultant force. Determine the resultant force. Determine the resultant force. And the point where its line of action cuts the side BC. Determine the resultant force and the point where its line of action cuts the side BC. And the point where its line of action cuts the side BC. Cuts the side BC. So please, this time you have to read the question fully. This time they want you to find where the line cuts the side BC. So you better make that side BC the horizontal in that diagram. You better make the side BC the horizontal. If you just draw a triangle, you may fail to get the point where it cuts a side. So this is the triangle. And don't draw it using freehand. So we better make BC the horizontal so that we can mention the line cuts the side BC when y is 0. So you better make that side horizontal. So this is point A. Now we have been given 10 newtons along AB. So we have 10 newtons here. We have been given 8 newtons along CB. And we've been given 3 newtons along really? Along CA. 3 newtons. So that's it. And this is now resolving this is not difficult, but the 10 and 3 we need an angle. But we have been told that the triangle is equilateral. So all angles are 60 degrees. So to resolve the 10 Newton's force, you need the 60 degrees here. To resolve the 3 Newton's force, you need the 60 degrees there. So you can even create the imaginary vertical lines, vertical and horizontal, but don't use freehand to include them. Don't use freehand. So that means this will be negative 8, 0. The resultant, x is negative and y is positive. Sorry, x is negative 8, no y. As we move to 3 Newton's force, the force is projecting out of point C, and so should the components. X is negative, y is positive. X is negative out of C, and y is positive out of C. So it will be negative 3 cos 60 and positive 3 sine 60 degrees. Then plus 10 Newton's force using 60 degrees is moving towards the point B. So x is negative and y is negative. Towards the B for 10 Newtons, x is negative, y negative. So negative 10 cos 60 degrees, negative 10 sine of 60 degrees. Yeah, that's it. So you can continue. We shall meet next time. No. The lesson. The lesson is done.
No.
Hey, so the lesson is done. It's already past time.
Thank you, teacher. Bye.
Thank you, teacher, for teaching.
Thank you, teacher. Teacher, bye. Bye, bye, bye.
Bye-bye.
Thank you, teacher.
You're welcome.
Thank you.
You're welcome. So please, next time you remind me.
Negative 8.
Hold on.
On the board after CA.
Bye. Are you done copying questions?
Wise. Like the negative 3 cos 60.
Sunshine.
This Guti, that's not where the thing ends. You continue. Aguti, continue. The year was 2009. Aguti, Rebecca, that's not where it ends. Okiria, the year was 2009.
Number 12.
Yeah. Uh-uh. 2009, number 12, Okiria. It is not a different question, please. 2009. Are you done copying the question?
Are you done copying the question? Yes?
Not yet.
You don't have pens? What has happened? You buy nice clear pens, which are faster.
John, you remind me next time.
To finish now. Teacher.
Yes?
Teacher. What of trapezium?
Trapezium. You can read.
Alright, teacher. Stop
On Monday. Hexagon and trapezium, next Monday. You have probability and start on Thursday by Mr. Kwa.
Discuss for your friends who don't have data.
Wednesday. Stop failing.
Discuss with your friends who don't have data who are afraid to join. Because you are only 115. You are 115 today and there's supposed to be 160 in class. So you hope those ones who are dataless, give them content.
Stop failing.
Well, let me just take a screenshot. I'll share it on WhatsApp.
Bye, Chab.
Okay, bye. Go and prepare food.
Bye, teacher.
Go and prepare food.
Okay, teacher. Bye.
Bye.